Welcome to the Stormsurf Video Surf Forecast for the week starting Sunday, January 6th. Looking at significant wave heights for the North Pacific Ocean, we see an area of disturbed weather off of California, and that in and of itself already is producing weather into the California coast, with much more to come, and then another system towards the northern dateline region, generating 30-foot seas, aimed mainly at the Aleutians and not of any particular interest. But a much more interesting pattern is forecast. Let's get into the details. As usual, we start our tour looking at jet stream level winds, and they are fairly impressive. These winds, up about 30,000 feet, help support the formation of gales, and when gales form, help direct their track. So right now we have a consolidated jet stream flow with winds to 170 knots, pushing pretty much straight flat off of Japan to the dateline, then falling into a little bit of a trough, and that's what we're kind of looking for. A trough. There's actually a trough there, a trough there, and a trough there. This is a dip in the jet, and what that does is help create a counterclockwise flow aloft and down at the surface, and that's kind of the hallmark. That's what feeds low pressure. Low pressure generates wind. Winds generate seas. Seas, as they radiate away from the fetch area, turn into swell. Swell, when it hits your beach, of course, makes surf. So we have a trough there, a little one. Another trough here in the Western Gulf, and another trough pushing into British Columbia and generating weather into California. And if you notice, actually this portion of the jet here, it was right over the Sierra earlier today, full-on jet stream level winds pushing in to the Sierra. Most lifts at upper mountains were all shut down due to zero visibility and strong winds. And even now, I-80 in California is shut down due to whiteout conditions. All right, so the jet stream is driving everything. And of course, we know what drives the jet stream. That's the MJO. And it's all in full effect right now. Let's put this into motion, see what happens as we get into Monday. Here you go. A little bit of a break maybe for California, it looks like, as the jet ridges to the north. Maybe create a little pocket of high pressure there. But here we go. Another trough building in the Gulf of Alaska and being fed by pretty decent, 150-knot winds. That should certainly make more low pressure. Another broad trough off of the Kuril Islands and Kamchatka. Moving out, you see the trough gets kind of pinched as we get into Tuesday, but cues up, right, pushing, looking ready to move on to the California coast and in that area up into the Pacific Northwest on Wednesday. More energy building off of Japan. Was that 1, 2, 3, 4? That's 170-knot winds again. And there you go. Look at this. Just things digging out again. Another trough building off the Kuril Islands. A broad trough filling the entire Gulf of Alaska. And here you go again. Boom. Trough there. Trough there. You get the picture. It's like a machine, literally. This trough pushes into California, it looks like sometime later on Friday, and the beat just goes on. Then another trough building off of California on Saturday. Same deal, broad trough again in almost on the dateline. And where do we go from here? Well, whoops, there we are. We're at 180 hours out, and just for laughs, let's go. Here we are right now. Is there really all that much difference between now and a week from now? Doesn't look like it. So the good news is lots of potential to generate storms. The bad news relative for California, probably a lot of weather. But the good news in that, well, hey, rain and snow. You take what you can get. Hawaii, pretty much south of all this, they'll get sideband swell from whatever gets generated pushing across the Pacific. All right, let's go take a look down at the surface. Here we are, surface level pressure, surface level winds. You can see small, weak little low pressure right off of California at the moment. Another one building north of Hawaii. Broad one off of Kamchatka, northern dateline region. Let's see what happens. This guy starts firing up here. The one off north of Hawaii builds as the remnants of the first system push into California on Sunday night. And instantly, boom, 55-knot winds aimed their north winds, maybe a little side band energy into Hawaii. In fact, let's take a look. We'll just sort of look and see if there's any fetch. Little bit aimed at Hawaii, so maybe some north swell from this one for Hawaii. But 50 to 55-knot winds, that storm force, and aimed pretty well at Southern California, Central California, down into the Baja Peninsula. And moving very slow. You see this front just pushed over central and northern California. much swell energy and wind energy likely. Another system building off of Japan as we get into Wednesday morning, and even maybe some remnant energy north of Hawaii, a new little system perhaps, and we'll see where this goes. Yep, there we go. Another broad gale off of California Wednesday night. A storm developing with 55-knot winds also approaching the dateline. That's 55, 60, maybe 65-knot hurricane force winds. That's pretty solid over a pretty good area aimed directly at Hawaii. And there you go. And then starting to swing to the west into Thursday morning. So here's another. So you see, here's the next system queued up, pushing into, getting ready to push into California later Thursday. Good system on the dateline. It's like a machine right now. If you actually look at this, you see 30-knot winds almost the whole way. You know, there are breaks like in here, but almost covering the entire North Pacific aimed to the west. Great for surf production, but also for weather production as well. So we're into Saturday here. Things moderate a little bit, but then it looks like another system developing west of the dateline, again aimed at Hawaii. Pretty nice. Now all of a sudden, Sunday, a little bit of high pressure trying to ridge into California. Is it a break? Will it make a break? Hard to say. We'll see. But maybe that could be, you know, it looks like it could be the end, but we know the jet stream's still got piles of energy in it, and here comes another low pressure system. So hard to tell, but a very stormy pattern for the North Pacific expected for the week. All right, let's go see what effect those winds have on the ocean surface. So here's the current state. We saw that. We know there's a gale developing here in the Gulf as of Monday. And there you go. 39-foot seas Monday, building to 43 foot on Monday night. 43 feet again Monday night, and into Tuesday morning. You can just see where it's targeted right here from about San Francisco south to somewhere down about midway down the Baja Peninsula. Probably a pretty good push of swell. You actually see 20-foot seas impacting California, the San Francisco area on Wednesday morning. Then another system building west of the dateline as we get into Wednesday night. And even a little tiny system. We're not even looking at things like this where earlier this year we've been, hey, look at that, there's 30-foot seas or something. Now we don't even care. Broad system Thursday morning on the dateline with seas to 58 feet. That is an upgrade from even the previous run of the model, and that was an upgrade from that one before that. And 60 feet now as of 18Z Thursday. Another system building off the California coast. And where were we at? 55 feet. This is a good, let's see how long this goes. Actually, okay, 51 feet. So Friday to, so from, let's say Thursday morning, bright and early, to Friday morning. 24 hours of 50-plus foot seas pushing 60 feet. You think there's going to be a swell generated by that? You can bet your bottom dollar it will be. And large for Hawaii. California looks to probably be caught in the middle of a storm machine when all that happens. Still, even like 26-foot seas into Sunday, still pushing through the Gulf. Here comes the next system, building west of the dateline on Sunday, moving fast, not getting as much traction, but still, swell result for that. Hawaii probably be the target of all this. In fact, watch this. We could probably just see the impact. Here's the seas hitting the Hawaiian Islands on Saturday night into Sunday. Large swell blowing right past the islands. Pretty significant event. Interesting. All right, let's go take a look at wind, local winds. Now, we kind of have a pretty good sense of what's going to happen for California. Like today, Northern California, southwest winds, south winds, blowing hard, driving rain, whiteout conditions in the mountains. Will that continue? Well, we suspect probably some variation on that. So we're into Monday. Hawaii, in the meantime, light north winds, not so good. We need some trades, but that's not going to happen. Big big system building. Oh, here comes a little bit of high pressure. Maybe that just will push some trade. There we go. Light trades into Hawaii. So get into Tuesday. Next system ramps up off the California coast. You see the picture. The dividing line seems to be somewhere down around, Big Sur, maybe something like that. All the worst of the weather seems to be north of that point. Anyway, front pushing into California Tuesday night into Wednesday morning. Light winds relative to Hawaii. And then here we come Wednesday night. Next system, a little bit of north winds here relative to Hawaii. Next system for California. Here comes the front. Let's see what it does for California. There we go, right down into somewhere around where that previous dividing line was. Trades into the Hawaiian Islands Thursday night into Friday. A little bit of clearing for California Friday night. Hawaii under a trade pattern. Here comes the next system relative to California. Front again as we get into Saturday night and Sunday. And then looks like a little bit of high pressure starting to set up. Broader high pressure. And there we are at 180 hours. Maybe a bit of a clearing come Monday. But it looks like north winds maybe clearing high pressure for the California coast. Trades into Hawaii. The precip forecast, we're just looking here literally at California. You can see the bullseye. Significant precipitation into the San Francisco Bay Area. That was as of 4 p.m., and that, in fact, was happening. Verified. Heavy snow in the mountains. That's verified, too. Pushing into the southern Sierra in the evening. So we get into Monday. Rain starts clearing for California for a little bit. Snow starts clearing by, let's say, late morning for the Sierra. Maybe they can dig out some of the lifts there. And then here comes the next system, rain into California. Now, this looks to be a little bit of a warmer one. Yes, there's snow, but not as significant. Higher elevations Wednesday into maybe Thursday morning. That fades out. Next system queues up the coast. Rain Friday morning, turning to snow for the Sierra. But that moves out pretty quick. And then yet another system as we get into Saturday night. Sunday, it looks like another pretty good snow event. Then it clears out, and there's your high pressure. Let's go take a look at some quick snow forecasts. Squaw Valley dashboard, GFS model, snow accumulations over the next week to 10 days, looking at about 43 inches or so of accumulation. Here's the actual snow events where the blue is, and then this is the accumulation of all of that. Here is snow levels. You can see top of the mountain, completely good the whole way through the period. Yeah, warming above freezing, maybe 7,000 feet. So that's, maybe the top of the Red Dog chair, something like that. A little bit higher maybe for a day, but there's no precipitation. You can see the yellow arrows. That's where the precipitation is going to happen. So that's no big issue. So it looks pretty good there. Winds. So let's talk about this for a second. Wind. Peaks. So peak elevation gusts in the red here, and peak elevation wind, the yellow. So right there, the jet stream is pushing right over the Sierra, so it's no big surprise. Gust to 100 and sustained maybe in the 60 knot range. And then as we move further out here, you see the wind starts settling down, the jet stream not pushing in quite as hard. We'll see what the models do, whether they back off or strengthen. Hard to say, but it looks like we're going through the worst of it in the Sierra right now. Kirkwood, about the same thing, 42 inches roughly over the next week or so. They are higher. Base elevation, 8,000 feet, so less exposure to warmer temperatures. And you can see they actually pick up 4 little events here. Interesting. And wind, a little bit more wind because they are higher, right? Makes sense. So something to be aware of. And then Mammoth, not quite so generous. So 13, 14 inches of snow, something like that. But very high base elevation. Don't have to really worry anything about rain or anything like that. And then wind, yes, still an issue given the high elevations. All right, so let's go take a look long term. What's driving all this? Well, we know it's related to the active phase of the MJO, so we'll dive into that. Then we'll have a discussion about what was El Nino and what it's doing now. So the first step in trying to examine the state of the MJO, the Madden-Julian oscillation, which is a periodic, it's pretty frequent oscillation, takes goes from the active state to the inactive state, takes about anywhere from 3 to 6 weeks to get across the Pacific. It travels on the equator from west to east. And the area we're mainly interested in is right here so here's the equator, here's South America, there's Central America, Australia, New Guinea, Philippines there. It's this area right in here from 135 east on the equator right there, 135 east to 170 west, 5 degrees north and south of the equator. When you get westerly anomalies, okay, and see we have westerly anomalies. They're a little bit south of the equator, but they're still in what we call the Kelvin wave generation area. If you get westerly winds, actually they start blowing over here in the maritime continent and go the whole way across. It takes warm water that's here, starts pushing it east. And what happens is it doesn't travel on the surface. It falls to depth like a big bubble, travels under the equator, then hits Ecuador and the Galapagos Islands and erupts on the surface. And that is what helps create El Nino if you have multiple of these Kelvin waves. Right now we're in the active phase of the MJO. We have a westerly wind burst scenario in effect. This was as of December 31st, and you can just kind of look down here, January 1st, 2nd, 3rd, and then the 4th, and fully significant westerly winds in control of the Kelvin wave generation area. If you're going to get a Kelvin wave generated, this is exactly what you want to see. And then here is zonal wind anomalies. So this is the whole planet on one chart. In other words, that's the date line right down the middle. Okay, the Pacific runs from about, we'll say 90 west to about 135 east, so right in there. But the Kelvin wave generation area is between about there to there. So we'll just go right up the chart. Okay, so here's what's happening today. And the oranges and the reds up here, positive. That's westerly anomalies. The blues are easterly anomalies. Westerly anomalies, winds blowing from the west on the equator. Normally there's trades, they blow from the east. So this is the exact opposite of normal. And you can actually go back in time and you can see this. So starting early December, you see westerly winds in the Indian Ocean moving slowly over the maritime continent and now in the Pacific and building. This is a classic westerly wind burst event. Great for building a Kelvin wave. Started January 2nd, we'll say. We're about a day past the prime. Yesterday was probably it. To continue for another 2 to 3 days. But even in that, it fades, but still westerly winds filling the Kelvin wave generation area. So when this happens, it's not only just creating potentially a Kelvin wave, but it's also imparting piles of energy into the jet stream, okay? Active phase of the MJO, strong active phase of the MJO, Madden-Julian oscillation, and that's feeding the jet stream. You saw the jet stream charts. You saw how strong the jet is, just raging on 35 north latitude line from North Japan right into California. That's about as good as you get. In fact, it's actually too much in terms of from a surf perspective because it drags weather with it, but it's great for precipitation and snow. So what's going to happen over the next couple of weeks? So this is the outgoing long wave radiation model. Another way of looking at the MJO, basically. The blues are areas of less sunlight reflectivity, okay, which means basically a bunch of clouds, which means low pressure. And that's the hallmark of the active phase of the MJO. It's acting like a storm that's traveling from west to east on the equator. And everywhere north of this area, the jet stream is enhanced, and the storm pattern is enhanced. So, active phase of the MJO, another 5 days, but notice as we get about a week out, it starts moving out of the Kelvin wave generation area, and the exact opposite, the inactive phase of the MJO, which is in the Indian Ocean, moving over the maritime continent, is expected to start seeping into the West Pacific. 2 weeks from now, inactive phase of the MJO is supposed to be over the Kelvin wave generation area. That would shut down the jet. That will shut down the storm track, and things would calm down significantly. That per the statistic model. Now, the dynamic model, a little bit more forgiving, suggesting the active phase, pretty strong still 5 days out, then weakening, but the inactive phase of the MJO dies. It doesn't really materialize. We just go back to kind of a neutral state. That's better. The jet stream could probably still hold together pretty good, and we could get some storms and some swell from that, but maybe not with all the weather. Let's look at phase diagram charts. So these are another way of trying to figure out where the active phase of the MJO is. So what are we looking at? Well, just assume this circle here. You're looking down on the North Pole, okay? And the MJO moves from west to east, from the Indian Ocean, over the Maritime Continent, across the West Pacific, over the East Pacific, underneath the United States, across the Atlantic, back to the Indian Ocean. The heavy dot is where the active phase is right now. So according to this, it's already out of the Kelvin wave generation area and maybe like, on the date line or a little bit even, this is probably like the leading edge, is a little bit east of the date line. The further away the dot is from the circle, like if it's way out here, it's extremely strong. So we're saying moderately strong. This per the ECMF model. The forecast is the green track, basically saying, yeah, it's supposed to race east for a week, then be very weak, but almost looks like it's supposed to start regenerating back in the West Pacific, if that's possible. The GEFS model basically saying the same thing, redeveloping very weakly in the West Pacific 2 weeks out. So maybe it is not all over yet. All right, wind anomalies from the CFS model, yet another way of looking at this. So again, this is one of those charts, whole planet on one chart. The Kelvin wave generation area between these two tick marks, the Pacific from here to about here, and here's where we are today. Now you can see this dark line is the active phase of the MJO, peaking over the Kelvin wave generation area. There's our westerly wind burst interacting with that red thing is an equatorial Rossby wave. So some of these waves all sort of interact, and when they line up just right, you get like westerly wind bursts. So that's pretty interesting. Now, part two of it is, though, see the purple, that's a low pressure bias. When they were talking about El Nino this year, this is the way they sort of depict El Nino. And now the interesting part is, per this model, it's supposed to continue on. And notice, these oranges and reds are westerly anomalies. They're supposed to continue for the next month in the Kelvin wave generation area, not die out. You have easterly anomalies pretty strong here over in the Indian Ocean. They're supposed to stay bottled up there, and that's because this low pressure bias thing is sitting right in the heart of the Kelvin wave generation area. So that suggests in a solid jet stream continuing. Maybe not as strong as what we have right now, but still pretty strong and helping to fuel the storm track. And that yet another model, 3 months out, same thing, CFS model, 850 millibar winds, that's about 4,200 feet, zonal wind anomalies. So this is past history down here, and you can see Kelvin wave generation area between these two tick marks you go up. You can see westerly anomalies, yeah, so that goes with the active and inactive phase of the MJO. Here we are right now, strong westerly anomalies in control of the Kelvin wave generation area, supposed to hold for about until January 14th or 15th, then weakening, but continuing on for the next 3 months. Let's overlay the MJO. There's your strong active phase of the MJO, the solid contour. And that's supposed to hold till about the 15th or 16th or so. Then we get into this longer inactive phase of the MJO, the dotted contour, but very weak, and still westerly anomalies in the Kelvin wave generation area. And finally, as we get into March, then the active phase supposedly is to wake up a little bit. Interesting. So if you're going to have surf and storms, of the large variety, now we are right in the bullseye of that, and that's clearly what's happening by looking at the wave models. And then once we get into the latter part of January and some part of February, probably not so active. Then in March, things wake up a little bit again. So let's overlay the low pass filters. So here, 3 contour lines. This is that low pressure bias thing we were talking about. This is the hallmark of El Nino, not La Nina, El Nino. But you notice it kind of backed off here in the middle of December, and now it's forecast to sort of wake up again as we get into late January. Not sure if that's really believable. This model is uncertain. Sometimes they show just a little area here. This is the best we've seen it in the past week in terms of the strength. We think this is a bit overhyped, but still a general environment favorable for storm production, and a decent solid jet stream looks forecast. All right, subsurface temperature profile, ocean. Okay, normally there was another chart that we like to look at from the TAO buoy array, but with the government shutdown, That site has gone dark, so we have to do with what we can get. But good, we have this other model from GODAS, and it's actually a higher res model. You can see this is the West Pacific here, East Pacific here. You see warm water. So this is down 50 meters, 100 meters, 150 meters. So the part we're looking at right here, so Ecuador would be here, and this would be like New Guinea off in here, something like that. This is just on the equator, 2 degrees north and south of the equator. You see warm water, so this is part of a Kelvin wave here. This cool part, interesting, I'm not sure what that's all about, but warm temperatures pushing into Ecuador. We thought there was another Kelvin wave developing back here, but it's just kind of, it's not a Kelvin wave so much as just reinforcing warm water pushing into the existing flow. This is just a steady flow that's set up all winter. Now the good news though is we know westerly anomalies were blowing over the over the maritime continent and are working their way into the West Pacific. We also see warm water starting to build way over here at 140 east. We think this is the beginning of yet another Kelvin wave. Now let's be clear, that probably won't do anything for us for this winter, because to get from here to here takes 3.5 months, 4 months, something like that. So we're into, you know, middle of April, something like that. But it maybe suggests that we're into a longer term pattern. This is just not like an El Nino. In fact, it's, you know, we're thinking that El Nino has not happened and it's not going to happen, but that we're just sort of into one of these maybe multi-year lukewarm spells. And that tends to be very good for surf production and for precipitation into California. So the short of it is, subsurface temperature profile looking pretty good. Sea level anomalies, another way of looking at the same thing, but this is JSON-2 satellite beaming radar down on the ocean surface. You strip out then all the waves, the tides, and what you're left with is what looks to be, so this is South America here, Galapagos right there, New Guinea there. You see this yellow and oranges, that is a bulge on the ocean surface. 0 to 5 centimeters here, 5 to 10 centimeters here, here and here. Also notice this little hole here. That's where the previous model said cool water sort of trying to reach to the surface, like a cool bubble right there, right off the Galapagos. So, hey, maybe so. Makes sense. Anyway, warm water at depth creates a little, you know, expands a little bit, and that causes this bulge on the ocean surface. We see warm water the whole way across the equatorial Pacific, just confirming what we saw in the previous chart, but also notice warm anomalies building here, or heights, I'm sorry, sea surface heights 5 to 10 centimeters here, suggesting that perhaps warm water is flowing out of the maritime continent and into the Pacific, driven by westerly anomalies right over here. This is the Kelvin wave generation area right there, suggesting maybe another Kelvin wave is developing. Upper ocean heat anomalies. So last year, so this is the West Pacific here. This is the East Pacific. This was the tail end of last year. We were in La Nina. I've already forgotten about it. Kind of hard to believe. It was so miserable. 2 years of La Nina, and it was horrid. Now, but you can see, what do you see? A whole bunch of oranges and reds. And we'll just slide this down. Starting in March, Kelvin wave number 1. Another little push here. It took a while. It's like a double push, double pump Kelvin wave before it finally pushed into the Ecuadorian coast in June. Kelvin wave number 2. Big westerly wind burst back in the August time frame, took very warm water, pushed it off to the east. That's where everyone started going, hey, maybe we got El Nino. Then there was another westerly wind burst and a little Kelvin wave. It really isn't a Kelvin wave, but you can see energy from, we'll call it just a second pulse of Kelvin wave number 2. And there's that cold pocket too. That's somehow still pushing in here. And then look over here. This looks like the beginning of yet another Kelvin wave. You know, this could be literally the upwelling phase of the Kelvin wave cycle. Kelvin wave, upwelling. Kelvin wave, upwelling. New Kelvin wave forming? Maybe. Hard to tell, a little bit early. All right, so what's going on at the ocean surface? So this is where we start having the El Nino discussion, right? 2 weeks ago, 3 weeks ago, lots of the oranges and reds are temperatures warmer than normal. And the classic El Nino pattern is you get, just like this, warm temperatures pushing across. Actually, what happens is they start developing here from Kelvin waves erupting over Galapagos and in Ecuador. Then the trades are blowing here, and they carry that warm water off to the west. And then if you draw a box 5 degrees north and south from here, right in here, that's what they call the Nino 3.4 region. And when you have warm water in here, and it's there long enough, 5 months, and it has to be half a degree above normal or more, then they declare El Nino. Okay, so yes, we have warm water there. Looks pretty good. But you know what? If it's a real El Nino, what you end up with is this sort of anvil or this triangle-shaped thing that starts building from here the whole way out to here and like that. We don't see any of that. We see this thin little weak stream, and it's actually weaker than it was last week, and it's weaker than the week before. I mean, it was looking pretty good there for a while, but now, and we kind of know why this is going on. I mean, there's a Kelvin wave that erupted, and the Kelvin wave died, and we didn't have any more westerly wind bursts, and there was no more energy to feed the warm pool, and so it's sort of just leaching off. Yeah, there's a bunch of warm water at depth, but it's not strong. It's not like this major flow. It's just like a steady stream of weak warm water. So we expect some pattern like this to probably continue. Is that enough to create El Nino? Probably not. I mean, yeah, there's warming off of Peru, but it's very weak. I mean, you'd want to see this whole area in here filled in, and certainly all this area in here filled in. We're nowhere near that. Then we go take a look over in the West Pacific. There's New Guinea. Yeah, there's weak warm water out to the date line, but nothing, just nothing real obvious. Should probably say nothing screaming El Nino. Okay, here's the trend for the past 7 days. Just sort of where you see the yellows and oranges, that's where things are getting warmer. Where you see blues, it's getting cooler. What do we have? Kind of a mixed bag. No like blazing reds anywhere in here. Nothing saying ocean temperatures are getting particularly warm. They're just sort of like this interspersed pattern of blue and orange and yellow. It's sort of like staying the same at best and then actually getting cooler in pockets. So nothing noteworthy there. The overall trend, well, you kind of get it here. See? A little bit of warming along Peru. A little bit of warming along the equator. How warm is it? Well, I don't know. Nothing super significant. There's this pocket of cooling right here. Again, you'd really want to see something branching like that. We're not seeing it. And up in here, we're not seeing it. Thin little stream, warmer, but not noticeably so. But you know what? This is way better than La Nina, because last year it was all blue in here. Now it's orange, so it's warmer. Jet stream's feeling it, but nothing over the top. But that's okay. We'll take it. Actual temperatures in the Nino 1.2 region, this is the area up along Peru and all that, and the Galapagos. Yeah. 0.2 of a degree above normal, 0.217. The trend, yeah, it was warmer there in November into December, but things have just bottomed out. It's creeping up, but anyway, this is a kind of a noisy area anyway. It's the Nino 3.4 region, the official El Nino monitoring region. And what do we have here? Well, we're at 0.488 today, which isn't even El Nino. You got to be minimum 0.5. So, but this stuff is very noisy day to day. NOAA officially only looks at it in monthly blocks, monthly averages, right? This is way down in the weeds. But if I just look at this and sort of eyeball, put a line, draw a line through this, I'm saying, yeah, we were maybe warmer, but the trend is 0.6, maybe 0.65, something like that. So October, November, December. So we're 3 months into what could be possibly construed to be an El Nino from a purely ocean temperature perspective. But there's more to El Nino than just westerly wind bursts, Kelvin waves, and sea surface temperatures rising. The atmosphere has to respond to it too, right? You get all that warming on the equator, especially off the Galapagos and all that, and one would think that would help feed the jet stream, which it does, but then the entire atmosphere needs to rearrange itself in response to those warming temperatures in the ocean. So there is this thing, the Southern Oscillation Index. It's real simple. Measure the pressure in Tahiti. Do it every day. Measure the pressure in Darwin, Australia. Do it every day. And then you sort of integrate the numbers and see what they come up to be. If you have negative numbers, like today's value is minus 8.66, hey, that's a good sign. That means the Pacific has energy. There's more low pressure over Tahiti than there is at Darwin. High pressure over Darwin, low pressure over Tahiti, that's a sign of El Nino, right? So what's the index been doing? Well, we looked the past couple of days, go, hey, it's getting more negative, or at least it was for a little bit. That's maybe a sign of the active phase of the MJO. And you see, we were pretty positive for this is a whole month's worth of data. So that positive numbers are the inactive phase of the MJO. Negative numbers are the active phase of the MJO. So we'll average it out. 30-day average. Let's see where we're at. Well, 5.15. And yeah, we're coming down from a high of 9.46, but we're still not even what I would say is the active phase of the MJO, though clearly we are, right? But you can see it's been positive. If you were in any sort of El Nino, all this stuff should be negative. The 90-day average, that's a good way for monitoring El Nino. We're at positive 3.97. If you were in El Nino, and El Nino's peaks typically right at Christmas, so we should be down at minus 10 or 15 at least. We're nowhere close. We're positive 3.97, and we've been positive for pretty much the entire past month. So, no sign in the atmosphere of El Nino. In fact, here's the 30-day SOI average, and this goes back January 17, so last year and this year. You see, it's, you could see these downward pulses. That's the active phase of the MJO. The upward pulses are the inactive phase of the MJO. This is neutral to weak La Nina. Same thing in I'm sorry. This is coming out of El Nino. This is weak La Nina 2017, early part of 2018. Then here's where everyone started talking, hey, maybe El Nino is going to start organizing. We see the average starting to get negative, but notice this. It's just been positive, 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 and it sort of just looks like if there was an El Nino, it didn't happen. It false start El Nino. So from a Southern Oscillation Index perspective, the atmosphere is not responding to the warm temperatures on the ocean surface. There's not enough warm temperatures. They haven't been there long enough. They're not hot enough. They don't cover enough area to really get the atmosphere to respond in an El Nino fashion. So really everything we're seeing is all driven by the active phase of the MJO. And then there's the ESPI index. Basically, same sort of deal. So the difference in precipitation, the area north of Darwin, Australia, and then the area over the equatorial Pacific. If this area is drier than normal here, then the index is negative. If it's wetter here, as it should be during El Nino, because if you have more warm water here, then you get more evaporation, you get more precipitation. If this is positive, and significantly positive, then you have El Nino. The index today, minus 0.24. So drier, very weakly, but drier than normal here. We're basically normal. So again, another index measuring different stuff, but saying the same thing. No El Nino. This is all kind of normal. So this whole pattern we're seeing is not El Nino at all. It is literally just the active phase of the MJO and a generally warming Pacific trying to push us towards El Nino, but not getting us there, at least not yet, and probably not going to. And then finally, the CFS model, temperature forecast for Nino 3.4 region. So this is the official El Nino monitoring region in the, we'll call it the central equatorial Pacific. Right now, it's saying temperatures are 1 degree above normal. We know that not to be true. They're about 0.45, somewhere about half of what's showing here, right? And the forecast is for those temperatures to hold for the next 2 months, then slowly start fading, but not fading off entirely, getting down to about, what's that, 3/4 of a degree above normal, then just kind of holding in October. This is the end of the model. We're into fall of this year, next fall. And temperatures, so even if they're half that, they're at 0.35 or something like that, that would actually be a hugely good thing, because then you have warmer than normal temperatures for a year and a half. And what that does is maybe start slowly nudging the atmosphere. It certainly would help support the jet stream being strong over the Pacific, and generally just, getting us out of kind of a drought mode and feeding the storm track as we get into the fall months. Now, the other part, too, is this kind of warmish pattern also bodes well for the summer this summer, 2019 summer, in the southern hemisphere. Not like anything ridiculous, but certainly enough like a return to a normal southern hemiswell kind of pattern, and then a return to a normal fall pattern as we get into the fall in the North Pacific. So, hey, not so bad. This gentle push, this gentle momentum actually can get you quite a bit and get you consistent, steady, swell-generating storms both in the northern and southern hemisphere if warm temperatures persist. So to wrap it up, short of it is jet stream, raging, fully in control, being fed by a westerly wind burst in the Kelvin wave generation area, generating westerly anomalies down at the surface. That's feeding the jet stream. That's filling the storm track. Multiple storms, multiple large swells expected. Pretty much stormy conditions for California. Not so much for Hawaii. Better, almost trades, consistent there. They're protected. So that's not bad. Also snow for the Sierra. Some inclement conditions. Pick your days carefully. You don't want to be stuck up there when it's, really raging. But anyway, a pretty positive outlook to start the new year. That is something to be thankful for. So that's it for this week. We will probably not do this next week. We'll do it the week after. We'll sort of play it by ear, see how things go, tracking the snow, you know the drill. So, but at least the week after, we'll do it again. Anyway, go get some waves, go get some snow, be safe, Happy New Year.